Hi, I'm Ms. Voon. Let's have a look at probability and combining events. So in the last video, we talked about a multi-stage event where we do something and then we do something else. Today, we're going to look at things happening at the same time. So first of all, let's clarify that the empty set is denoted by this symbol and it doesn't have anything in there. It is different to the set that contains 0. 0 is something. The empty set is completely empty. So here we have two words that we often use, union and intersection. Intersection is that middle part. Union is all of that. The graphics on this video is not very clear, but the A and B, that section is also colored. So union is everything combined, intersection is only the overlap. So we represent union by the symbol here that looks like a U, and we represent the intersection like a lowercase n. We refer to or for union and for intersection, and plus for union and times for intersection. For example, the example we did in class was if you're a boy or you're wearing a jacket, put your hand up. So if you're either, you would put your hand up. But when I said if you're a boy and you're wearing a jacket, put your hand up, then only the boys that are also wearing jackets are putting their hand up. So people that are both or the overlap. And we know that if we are adding fractions, we get a bigger number. When we're multiplying, we get a smaller number. So we can think of the probability of winning the lottery today and tomorrow, or the probability of winning today, the lottery today or tomorrow. Which one has higher chance? The probability of winning the lottery today or tomorrow. So adding will give me a bigger number. So all means adding. So union is when the union of A and B contains all the elements in A and B, whereas the intersection contains a set of elements that are in both A and B. So in simpler words, I like the statement more. The union is when it satisfies any condition, whereas the intersection has to satisfy both conditions. So intersection is the fussy one. So how does what other words we need to know? A, if that's A, then all of the rest is the complement of A. We've seen that in previous videos as well. And together, A and the complement, or A and A dash, or A and not A, adds up to 1. Disjoint sets look like that. And when we say they're disjoint, we also call it mutually exclusive. And that's when the intersection doesn't exist. See, remember that null set we introduced at the start of this video doesn't exist. Here we have an example. Let me lower myself so you can see. It's supposed to be a thinking bubble. So here we have 10 objects, 7 are round and 5 are blue. Whoops. Let me recap that. So here we have example 1. There are 10 objects up here, 7 are round and 5 are blue, and 1 is neither. Let A be round and 5 blue. So this is a very, very easy example so that we can label and talk about these using the correct words, and then we'll go on to a much more challenging example. So when we say round, means we're putting the round objects in A, and when we say blue, means we're putting the blue objects in B, and whatever doesn't fit, we're leaving it in that empty space outside. So we can see that there are 4 things. So the 4 on the left side of A, there's 3 in the intersection, 3 that are round and blue, and then we have 2 that are blue that are not round and 1 on the outside. So when we describe A, we describe that 4 and 3. When we describe B, we describe the 3 and the 2. When we describe the intersect, it's the middle, the 3. When we describe union of A and B, that's 4, 3, and 2. So when we describe this side, we're saying A, but not in B. Whereas this side is B, but not in A. And this is not in A and not in B. How would you represent this? So this one is A intersect not B. This one is B intersect not A, or we can write it as not A intersect B. And this one is the intersect of not A and not B, or the union of A and B, and then the complement of that. So you would do it as inside the bracket, so it will be A and B colored in, and then do the outside of the bracket. The dash means the opposite of that, or the complement of that. Make sure that you're comfortable with these symbols. If you need to visualize it, you would draw A, so you'd color all of A, you'd color not B, so the outside of B, and when intersection, you would think of what have I colored twice, which is this area here. You can do it for all of these ones. Okay, example 2. In a survey of 100 students, 60 students own smartphones, 45 own bikes, and 35 own boats. Let's do a Venn diagram. So we're going to pick S for smartphones and E for bikes. Now, instead of writing 60 students inside the circle, which is confusing, we know 60 is the whole circle. We're going to write it outside like that. Same with the bikes. So we know there's 45 and we're going to write it outside. So that 45 is going to remind me that inside the circle should add up to that. And then 100 students is the total. The total always goes next to the epsilon symbol over there. So that's the total. So whenever you need to check your Venn diagram, you add all the numbers inside and it should add up to that. What's the next piece of information? 35 own both. So let's put that in the middle. Then we think what goes into this space here. Well, we know from the really well organized numbers that we put, the 60 is the circle, so 60 minus 35 would give us the 25. Likewise, we can see that the 45 adds up to this circle, so we know straight away that that space there is 10. See how handy the numbers out there are? Make sure you label it like so. We also know that 100 is supposed to add up to that. Well, we know 25 plus 35 plus 10 is 70, so therefore in this space here, it must be 30. Double check. 25 plus 35 is 60, plus 10 is 70, plus 30 is 100. 25 and 35 does give us 60, and 35 and 10 does give us 45. So these numbers outside are really handy. You'll be marked on this section, but these numbers out there help you obtain the correct values. So now I'm just going to move it down here. So let's do some questions. How many students own neither smartphone nor bikes? So not smartphone and not bike, that's that 30 over there. Next question, how many students own either smartphone or bike but not both? So smartphone and bike but not both. So the 25 and the 10, so 35. If a student was selected at random, what is the probability that they own a bike but not a smartphone? So bike but not smartphone, so the 10 out of the 100, sorry, which is 1 over 10. So now we can talk about the addition rule. So we can see that A plus B is going to be not A union B because we added the intersection twice. So if I go back to the example before, we can see that if I just simply said S union B and I took 60 plus 45, we can see that we have 105. And 105 is not S union B, is it? 105 is too much. So how come when we add S and B, we get 105? That's because we accidentally added the 35 twice. So to obtain what's S and B, 25 plus 35 plus 10 is 70. To obtain the 70, what must we do? We must do 60 plus the 45 and then subtract 35. That gives us 70. Recap, so the S, 60, plus the B, 45, minus the intersection. That gives us the union. So A union B is A plus B minus the intersection because we've added it twice. So this is the addition rule. But when we are mutually exclusive, so there's nothing in the middle, it doesn't matter because A intersect B it should be the null set, not a 0. A intersect that section there is 0. So when you do A plus B minus 0, it's still the same. So it's just A plus B. So the addition rule, so A union B is just A plus B. So recap, so if you're mutually exclusive, it's just A plus B. Let's do example 3. There are 18 students in the class, 7 students swim freestyle and 4 swim backstroke. 2 students swim both. Draw a Venn diagram and use it to find the probability of the following questions. So freestyle and backstroke, again 18 in the class, so 18 goes on the outside, and we have 7 freestyle and 4 swims backstroke, so on the outside as well. So all the outside numbers first. Then the next bit is 2 students swim both freestyle and backstroke. That goes in the middle there. Now that circle has to add up to 7, so that's 5. And that circle has to add up to 4, so that's 2. And 5 plus 2 plus 2 is 9. And that whole rectangle is supposed to add to 18. So that space there is also 9. Double check. 5 plus 2 plus 2 plus 9 is 18. 5 plus 2 is 7, 2 plus 2 is 4. So I've checked all my numbers. Now let's answer the questions. The probability of swims freestyle, so F, so that's 7 out of the 18. The probability of backstroke is 2 plus 2 is 4 out of the 18, simplified to 2 over 9. And swims freestyle and backstroke, that means the 2 in the middle, so 2 over 18 is 1 over 9, and is on the swimming team, so A union B, so that is 7 plus 4 is 11 minus intersection is 9, or you can see from the Venn diagram it's 5 plus 2, so 9 over 18. And notice the symbol of swims freestyle and backstroke, or freestyle or backstroke is union. Let's do 2 examples to be very clear about mutually exclusive and when you're not mutually exclusive. So if the probability of A is obtaining a 2 over there, and a probability of B is obtaining a 6, then we can clearly see there is no intersection. So obtaining A or B is just A plus B, so 4 out of 52 plus 4 out of 52 means 8 over 52, which simplifies to be 2 over 13. Oops. Sorry about that. So this is mutually exclusive because the intersection is the null set. It should be the one with the line. So the A union B is just A plus B. But if there is an intersection, like for in this case, if A is 2 and B is, say, diamonds, then we have a number in the middle. So when we're adding 4 for the 2 and then 13 for the diamonds, we obtain 17, which we can clearly see it's too much. Let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It should be 16, not 17. Why did this happen? Because when it's not mutually exclusive, we have added A and B, but we also have to subtract the intersection, that 2 that we accidentally counted twice. So now it becomes 16 over 52, which simplifies to be 4 over 13. So in this case, we're not mutually exclusive. So it's A union B is A plus B minus the intersection. Okay, don't forget to simplify that. Don't leave it at 16 over 52. Thank you for watching. I'll see you next time. Bye.